NDT, that means non-destructive testings, are first visual check, then paraffin and whitewash test, then magnetic particle test, then hydraulic test, stethoscopic test, air pressure test, radiography test, ultrasonic test, eddy current test, and dye pattern test. So we will go through all these 10 tests. So let's go on the first point, visual check. Visual check is nothing but the inspection done by a skilled worker by his naked eyes. So basic 3 points are considered over there. First is physical dimension of the weld, right? Second one is penetration weld metal, and third is surface defects. So physical dimensions of the weld is nothing but, let's say the setup of this welding butt joint is over here. So the physical dimension of the weld means the length of this object, the length of this particular V groove. The V groove is made over here, which is having a 60-degree angle. You can see one gap is there, which is of having 2 mm, right? So this kind of things are used to be checked before doing welding. Then penetration weld metal. Penetration weld metal means the weld metal which is going to be deposited over here. By melting the electrode, it should penetrate up to its crater area. Crater area means the lower area. Then point number 3, surface defects. So the place where we are going to weld, that place should be neat and cleaned enough. So this thing is usually checked by a worker. Also 3 things are there. First is before welding, second one is during the welding, and third one is after welding. Now before welding means the surface is checked for contaminations like dust, oil, grease, and scale. The cut edges are checked carefully for presence of burns. So before doing welding, the gap, the groove surface, all these surfaces are required to be cleaned enough. Now next, during the welding. Now welding process parameters, welding consumables, preheat, interpass temperatures, placement of weld run, distortion control, heating temperature and time, etc. These different things are checked during the welding. How many number of passes are going to be done? After each and every pass, we have to clean the welding. That kind of things are considered in this second step. Now third is after welding. After welding, we have to check the welded joint for accuracy as per the drawing. We have to check different defects like undercuts, spatters, roughness, pits, left without weld metal filling, and overlap. So this is nothing but the basic welding inspection which is required to be done by all the welders. Okay, so first topic is completed, visual check. Now let's move on to the next point, paraffin and whitewash test. This test is basically used to find the surface cracks. The cracks or defects which is on the surface of the job, it can be detected by this particular test. So what is done in this particular test? The weld is first painted with paraffin and then dried. So you can see now at number 1, this is our job. Crack is visible over here. So first we have to apply a paraffin which is of white color liquid, and we have to let it to be dried over there. Then next you can see point number 2 is here. Then whitewash is applied and it is also allowed there to be dried. So what will happen if cracks are present on the surface, then the oil lines of this particular paraffin will be developed over here. So we can easily identify crack over here. Okay, so this was the very simple test. Now third one, magnetic particle test. So magnetic particle test is used to find surface cracks as well as subsurface cracks up to some level, maybe up to 10 mm to 15 mm. We cannot go more than that. It cannot detect defects beyond that surface. So the crack is basically found out by attracting iron oxide by magnetic system in this test. So let's see the principle of that. Let's say I'm having a magnet over here which is having North Pole and South Pole. If this bar is broken in two parts from the center, then two parts or two bars, or we can say two magnets with magnetic poles on each end of each piece. If the magnet is just cracked but not broken, just like this, if magnet is just cracked but not broken, it is not broken in two parts, it's just cracked up to some level, then this area will create a north and south pole at each edge of the crack. So what is happening over here? The magnetic field exits, you can see the magnetic field exits the north pole and re-enters at the south pole. How it occurs, I will show you in the next slide. Right, so just see how magnetic particle test is conducted. One yoke is used in which coil is there, you can see coil is there. When we will pass the current from this particular electric cable, it will generate some electricity. So due to that, these magnetic bars, or you can see these two magnets, will generate magnetic field. So when an electric current passes through the component is over here, you can see, and we have to identify the crack. Okay, so when an electric current passes through the component, then magnetic field come into existence in perpendicular direction. As I was telling earlier, the magnetic field exits the north pole and re-enters at the south pole. So you can see it is coming out from the north pole and goes into south pole, and again it comes out from south pole and goes into north pole. So let's see the new figure. If there is any discontinuity, just like this, in the material between two poles means north pole and south poles, then another pole, north pole and south pole, comes into existence. That means at this point there will be north pole, and this point there will be a south pole. So due to that, lines of magnetic force does not remain continuous. You can see the lines of this magnetic field does not remain continuous. So there will be a leakage of current due to this particular defect. So what do we have to do in this particular test? Iron oxide powder is applied on the component. Then the powder gets accumulated at the place of defect where newer poles are developed. As I said earlier, there will be a north pole, and over here there will be a south pole. As the accumulation of powder, which will be over here, that will indicate the place of defect. So this test is used to reveal the same on surface and subsurfaces. So you can see the crack is over here, iron particles are sprinkled over here. So due to this void or vacant space, magnetic field lines are discontinuous. So the particle will be attracted towards each other and make a cluster, right? So the cluster of particles indicates that some defects are here. Even if there is a subsurface defect like crack, not at the edge of this particular area, if crack starts from here to this point, it will also detect the crack. Okay, so now we will see some advantages and disadvantages of magnetic particle test. So in advantages, it is very fast, simple and inexpensive. We don't have to spend a lot of money. And second one is direct visible indication on surfaces, right? Then third point, it can be used on painted objects. It doesn't mean that non-painted objects are used to get the defects. We can also apply this test on painted objects. Then surface preparation is not required. That means we don't have to clean its surface, we don't have to grind it, we don't have to rub it, just let it be as it is. We can check this particular object also. Now disadvantages. It is only good for ferromagnetic materials because only ferromagnetic materials can pass the magnetic fields. So it can be applicable to ferromagnetic materials only. Diamagnetic material will not be applicable to this particular test. Okay. So next, subsurface defects will not always be indicated. So this subsurface defects will not always be indicated. If subsurface defects will be lower than 1.5 centimeter or 2 centimeter, so from this top edge area, if the crack is over here, so it cannot detect that particular crack. Objects must be demagnetized before and after the examination, because whenever this material is magnetized by this particular yoke, it can attract other ferromagnetic materials also, so we have to demagnetize it. Okay, next test is hydraulic test. This test is basically used to inspect pressure vessels. After ascertaining that vessel is defectless, the vessel is filled with water. The name itself says we have to do a hydraulic test. That's why we have to use some liquid or any other things in liquid form. So we are using water over here. So we have to fill this vessel with water fully. A pressure gauge is fitted at the top of the vessel to measure the pressure inside the vessel. Then we have to increase the pressure by a pump and take the reading of the pressure gauge. So this pressure should be maintained or obtained twice than the pressure for which the vessel is to be used. So what will happen if moisture is present at any place around the weld? Basically these pressure vessels are made by welding different components. So if any defect, any crack, any void is present at the welded area, so what will happen due to the pressure of this water, which is maintained at twice than the pressure, so if moisture comes out from that particular area, so we will come to know that there is some crack or any kind of defects. So if moisture at any place around weld is found, then it is the indication of crack or porosity in the weld. This is what hydraulic test is. So till now we have seen few non-destructive tests: visual check, paraffin and whitewash test, magnetic particle test, hydraulic test. So rest of the test will be covered in next lecture. Thank you. Hello everyone. In last lecture we have discussed few non-destructive testings: visual check, paraffin and whitewash test, magnetic particle test and hydraulic test. Now let's see another test. The next test is stereoscopic test. In this test, the weld is observed by striking the hammer on the weld. You can see one hammer is indicated over here and one stereoscope is here. So what is basically done in this test? The weld is observed by striking the hammer on the weld and hearing the sound which is produced by striking the hammer. If weld is defect free, then metallic ringing sound will be there, and if there is any kind of defect in the weld, then there will be a dull sound. And it can be compared with a defect free bell, because the bell gives sharp and high intensity sound when there is no defect in it. This test is usually check pressure vessel and structural welds. This is a simple kind of test. Now next is air pressure test. Air pressure test is similar to the hydraulic test which we have seen earlier. In this test, for increasing the pressure inside the vessel, air is used. So it is easy to test pressure vessel by this method. One pressure gauge is used to know the pressure inside the vessel. Soap water is applied on the weld area which is to be tested. When the vessel is under pressure, airflow will cause bubbles to form at the place of defect, from where leaking is identified. So wherever the weld is done on pressure vessel, if there is any kind of void or crack or any other vacant space, the soap water is applied, and if any crack is present over there, then due to the air pressure, the soap water will be converted into a bubble form. So this particular test is basically done during the time of installation of gas pipelines which is installed in our home. So this is a simple kind of test. Now next is a radiographic test. Radiography is an imaging technique using X-rays to view the internal structure of an object. For radiographic, X-ray generator is used and is projected towards the object. The radiation used in radiography is a higher energy version of the electromagnetic waves. It is nothing but the part of electromagnetic waves. The radiation can come from an X-ray generator or a radioactive source. So let's see how it comes from a radiation source and how it is projected on this particular film. When rays are thrown on the component from X-ray source, then they absorb equally in whole area, and the image formed on film gives same intensity. But when there is any defect in component, unusual absorption of ray giving the change in intensity. So if in this particular part, if there is a void or crack is there, then the rays which is coming from a radiation source will be observed over here, and the intensity of that particular area will be different from the adjacent material. So the part is placed, you can see part is placed between radiation source and a piece of film. Radiation source is here and film is over here, right? The part will stop some of the radiation because part is a solid form, so it will absorb some radiations. Thicker and more dense area will stop more of the radiation. The more thicker the path is, the more radiation will be absorbed. So you can see over here less exposure is mentioned here and more exposure is mentioned here. So if crack is there, then there will be a less exposure, right? Because radiations are not absorbed here as compared to the adjacent part. So it is simple kind of thing, but we cannot find out how much deeper it is. So let's go through its advantages and disadvantages. First point, it detects both surface and subsurface defects. It detects, but it doesn't says it detects both surface and subsurface defects, but subsurface defects are not clarified how much deeper it is. Point number 2, it provides a permanent record of the inspection because it is recorded on this particular film, so it will be a permanent record. It can inspect assembled components. And last point, it has a very few material limitations. Now next, disadvantages. Its equipment is costly. X-ray is injurious to the health of the operator because it is having a high intensity light. Then high degree of skill and experience is required for this radiographic test. And last is depth of discontinuity is not indicated, as I have discussed over here on the first point of advantages, subsurface defects. How deeper it is, we cannot clarify. Okay. Now next is ultrasonic test. Ultrasonic test is based on the pulse echo method. Acoustic waves are generated by ultrasonic machine. So this ultrasonic waves is the waves with having frequencies from 20 kilohertz to 20 megahertz, which are induced pulse-like into the workpiece to be tested by a probe. The pulse duration is usually a few microseconds. These sound pulses propagate in the workpiece. These sound pulses will go into the workpiece with characteristic sound velocity. So let's go through this particular figure. You can see one object is here, one probe is here, which is used to check the defects. One CRO is there, cathode ray oscilloscope, on which we will see how much amount of crack is there. That means according to the distance covered by this particular ray, by this particular wave, we can come to know how much deeper the crack is. So you can see when no foreign material or no inclusion or no any defect is there, the wave is coming from the transducer and it is going back again to the transducer in a particular waveform, right? So when any defect comes in the path of the pulse wave, if any defect comes in the path of this pulse wave, these waves get reflected from that particular point. So this is indicated over here in crack. You can see crack echo is there. So whenever any defect comes in the path of that waves gets reflected back. It doesn't cover the whole distance of the object. It will go from this particular defect. So it can be viewed in CR of the equipment. you can see over here, when there is nothing inside this object, the waves was not changing. When there is a defect, this wave is changed over here. You can see the flow echo. From the CRO, cathode ray oscilloscope, you can easily identify how deeper it is. Okay. Now, advantages and disadvantages. It is fast and reliable. It is more sensitive, hence very fine defects can be found. This method is effective even for large size components. Disadvantages. Surface to be tested should be smooth and clean because this probe is kept on the surface of the job, so its surface should be cleaned enough. Then skilled workers are required to note down the digital readings. Then third point is non-applicable to complex shape and design, right? So if a part is having a complex shape, then it is not useful. The next is eddy current testing. Now this method is applicable to electrically conductive materials only because its name says eddy current testing. So current can pass in only conductive materials. So in this method, eddy currents are produced in the product by bringing it close to an alternating current carrying coil. So what is eddy current? Electric currents are generated in a conductive material by an induced alternating magnetic field. The electric currents which are generated due to this thing is called as eddy currents. In this test, a generator is used, a coil and recording equipment, that means a galvanometer or an oscilloscope is used. So you can see over here, one coil is there. When an alternating current passes through a coil, a primary magnetic field will be generated around that particular coil. The alternating current primary field induces circular eddy current in the object which is held below the coil. So this secondary magnetic field arises due to the eddy current. As I was saying earlier, electric currents are generated in a conductive material. Electric currents are generated in a conductive material by an induced alternating magnetic field. The electric currents are called eddy current. Okay, so whenever we will pass the current to this particular coil, it will induce some current. So in order to generate eddy currents in an inspection, a probe is used. A probe is having a primary coil. So eddy currents flowing in the material will generate their own secondary magnetic field. That means the eddy current which is generated on the object, it will produce its own secondary magnetic field which opposes the coil's primary magnetic field. So if crack is present on the object, it causes a disruption in the circular flow pattern of the eddy current and it will weaken their strength. This change in strength at the crack location helps to detect because the impedance which is produced due to this primary magnetic field, the impedance which is produced over here due to the primary magnetic field, it will be in a circular form. But if there is any crack, then there will be irregularities of this magnetic field. So the impedance is changed. Due to that, this primary coil's magnetic field will be changed. So that thing will be noted over here on galvanometer, on oscilloscope. You can see, just see this object and see this pointer. In our concept, we are moving this probe, we are moving this coil around the job, but in this thing, job is coming into this particular coil. When job is coming inside the area of this coil, it will get changed because crack is there. If crack wasn't present, then this current meter will not be changing. Now advantages and disadvantages. It is high inspection speeds. Now advantages and disadvantages. It is having high inspection speeds. It can detect flows through paint layers. It doesn't mean we have to go through only non-painted products. We can also check painted products. test probe does not need to be in a contact with the part. That means the contact is not necessary. Disadvantages: only conductive materials can be inspected because eddy current is required to be produced. So only conductive materials can be inspected. Skill and training required. Surface finish and roughness may interfere because if surface is not smooth, there will be a change in current due to the change in magnetic field. Now next is dye penetrant test. This is one of the most important and mostly used test in industry, dye penetrant test, which is basically used for checking surface cracks. So what is done in this particular test? You can see liquid penetrant is applied to the surface of the component and is permitted to remain there for sufficient time to allow the liquid to penetrate into any defects. After the penetrant time, the excess penetrant which remain on the surface is removed. Then a developer is applied to the surface. This developer draws out a portion of the penetrant which had previously seeped into the surface openings. So what do we have to do? First we have to apply a penetrant which is of red color maybe. Thereafter we have to let that penetrant over there for seeping into the crack. So after seeping into the crack, the upper portion of the object, upper portion of the workpiece is cleaned by water. Thereafter a developer is applied to the surface. This developer draws out a portion of the penetrant which had previously seeped up or soaked up into the surface openings. As the penetrant is drawn out, it diffuses into the coating of the developer, which will show the defect. So you can see how dye penetrant test is done. First, we have to clean the test piece. Thereafter, penetrant will be used. Apply penetrant all over the workpiece. Then it will go into this crack if crack is present. We have to allow it to soak or seep. Then rinse the test piece. A rinse of the penetrant from the top surface of the object. Then developer will be used, which is of powder form or liquid form, which is having white color. After applying developer, we have to wait. So the developer will soaked up or seeped up this particular penetrant. So this thing will indicate us that something is present over here, just like a crack, right? So this was the thing with the dye penetrant test. Let's see its advantages and disadvantages. This method is simple. More skill is not required. It can be used for metals and non-metals. Then disadvantages. It cannot be used for porous component. And next is internal defects cannot be found. As I have told you earlier, in this test only surface defects are detected. We cannot go through the internal defects. So in this lecture we have covered all the rest of the test: stereoscopic test, air pressure test, radiography test, ultrasonic test, eddy current test, and dye penetrant test. Stereoscopic test, in which hammer was used for striking the object. By striking the object and hearing the sound, we can come to know if there is any crack or a defect. If there is a dull sound, then there is a defect. Then air pressure test. It was similar to hydraulic test, but in this test air was used for increasing the pressure. Then radiography test, in which X-ray was used to find the cracks or any other defects. But in this test we cannot know how deeper our defect is. The next was ultrasonic test, in which pulse waves were used to find the crack. So in object, any defect is there at any level. By pulse waves we can easily find out how deeper our defect is. The next was eddy current test, in which one coil was used that coil will produce a magnetic field, and due to that magnetic field in the part, eddy current was there. Eddy current were in circular form. So if there is any crack or any irregularity on the surface of the job, that eddy current's impedance will cause an effect to the primary coil's magnetic field. So this change will be indicating us how defect is. And last one was dye penetrant test. In dye penetrant test, first we have to clean the surface of the job, thereafter we have to apply the penetrant, then let it be over there for seeping up into the crack, thereafter we have to rinse it off from the surface of the job, thereafter we have to apply a developer on that particular surface. So the developer will soak up the previously placed penetrant. So if developer is showing a red color, we will come to know there is a crack on the surface. So in this lecture we have covered all these non-destructive tests. Thank you.